Hi, good morning everybody. My name is Patrick Callaghan. I'm going to be talking to you today about data modeling for Apache Cassandra. We have about 25-30 minutes, so it's quite a big topic, so I'm going to go through this quite quickly. But what I want you guys to get out of it is how companies are building products with Apache Cassandra and what are the real use cases for that, and how to change and understand how to data model for those use cases. Just quick show of hands. How many people have heard of Apache Cassandra? Wow, brilliant. Okay. Okay, sorry. It's not changing. Perfect. Okay, so very quick agenda. It's going to be blazingly fast. So what is Cassandra? Very high level in terms of the architecture of it, because that kind of lets us understand how we have to partition and data model our data to make sure that it's distributed properly. We get into data modeling, the little tips and tricks. We're going to look at use cases. How are people using Apache Cassandra to create these massive big data use cases? Cool stuff. So some of the tips and tricks around the data model itself, things like TTLs, time to lives. We'll get into a little of a few things that are really helpful. We'll also talk just a little bit about Apache Spark, just in terms of Apache Spark is a distributed processing engine or analytical engine, and it works very well with Cassandra. Okay, so guys at the back, you won't see this, but this is a really good slide. It's an infographic around what happens in an internet minute. Right? You can look this up yourselves at a later date. But it tells you about all the things that are happening in some of the biggest applications in the world in 1 minute. Right? So you can see about 1 million people log into Facebook every minute. But that's nothing to do with like just looking at their their feeds and their messages and all that. It's just logging in. Apparently 700,000 hours of Netflix is watched in a minute. Don't know how that happens. But this basically is the world we live in today, right? This wasn't even capable 20 years ago. And the difference, the thing that changed was relational databases were kind of combined or overtaken by NoSQL databases. And what that allowed was this idea of distributed databases. You've all probably heard about distributed computing, distributed databases. But how it works is trying to get lots of different computers together to work as a team, basically. So this idea here is this is a Cassandra cluster, right? And a cluster can be spread across data centers. It can be in one data center. It can be in multiple. Each of these is a node. So a cluster is made up of nodes. And all these nodes this could be a VM instance, it could be a container, it could be a machine. Doesn't really matter, it's just the compute resources. When we talk about partitions are grouping data together in a logical or physical structure, so it makes it easier to understand that data and query it and manage it. Right? So you can think of each of these nodes as having a partition of data. And each of those partitions have keys. So if you think about it, a very simple example, there's 8 nodes here. If I had a database of 8 million customers, I would expect to have 1 million customers on each node. Right? So 0 to 1 million, 1 million to 200, or 2 million, and so on. So what happens then is when I come to my cluster and say, well, I want customer 4,274,000,000, whatever, thousand, it automatically knows where it is. It says, yeah, okay, this guy owns between 4 million and 5 million. And I can go straight to that machine and get my data. So partitions and partition keys are really important. And when you think of that as well, I'll keep going. So that's how data is structured, right? It's partitioned, so you need a key to get into that node, that machine where your data resides, and then get to the data itself. So why is this important, right? Well, first of all, the partition keys allow you to distribute data evenly across the entire cluster, whether you have 8 nodes or you have 8,000 nodes. You want the data to be evenly spread. You don't want hotspots in your data, right? You don't want this node to be taking half of the whole database and everybody else doing nothing. Right? The other thing is you want to be able to have efficient queries. So I, as a customer, want to be able to say, well, I am customer 4,472,000. I want to be able to go there, get my data, whether it's, if I'm a bank customer or something, I can get my account, but I can also get all my account transactions, my loans, my mortgages, all from this node. I don't have to talk to all the other nodes. Right? So it's what we're doing is this kind of idea of spreading the load across all these machines, so that one, I can scale this, right? So I can go from 8 to 16 to 10,000 if I need to scale my data. But also, there's no contention. I can run huge amounts of queries in parallel. Because I might be querying this one, but someone else might be querying that one, and someone else is querying this one, and so on and so forth. So now, when you think about how many people are logging into Netflix or logging into Spotify and playing songs, you can see that actually we can go from 20 million to 30 million to 50 million customers very, very quickly. Anybody know the biggest user of Cassandra in the world? Apple. So Apple used this is last year, 160,000 instances. 160,000 machines, all working as, now this is over thousands of clusters, so they have a cluster for text messages, or iCloud, or your health, or your Find My iPhone, whatever it is. But basically, if you use Apple or Mac OS, everything is using Cassandra underneath, pretty much. So you can see that, I'm not labor the point, but Apple are the biggest users, followed by people like Netflix, Spotify, Instagram, Uber. I could go on and on. You could probably half the apps on your phone are the critical database behind them is Apache Cassandra. Okay. So the data model and why the data model is important. At the basic level, right, when you think about all these apps that we looked at, the Facebook, the Tinder, the Uber, whatever it is, they have two types of tables. One is an entity table. These are fairly straightforward, right? This is a thing. It might be an iPhone, it might be a person, it might be a bank account, it might be a sensor on a car, but it's a thing. Doesn't change that much. But that's a very simple entity. The other thing that's really important is the relationship to the thing. So I, as a user, Netflix user, I have an account. But I also have my recent history. I have my recommendations. I have my list. You know, all the things that are related to me. Similarly, if I am a bank user, I have an account. I have many accounts, and each account then has transactions related to that account. So these are the things that we actually care about. I'm not saying we don't care about the entities, but these are the things that are analytical in nature. These are the things we count and we categorize and we look at in detail. This is what's happening in our business. Okay, so simple examples. Entities. Now, I do a lot of IoT work because obviously this relationship is very suited to IoT use cases. But financial instruments, cell phones, music accounts, you can think of your Spotify, your Netflix, anything that you use on a regular basis that has data associated with you. Think of your Twitter feed or your Facebook feed. All these things are related to you as a person and not to anybody else. So they're just examples of these different things. Just checking my time. So an entity, as you imagine, right? It's a person, it's a thing, it's very simple. It's probably you've done 1 million entities in your life if you've ever done any database work. And in Cassandra, that's basically your primary key is your entity ID, right? Again, very simple, don't have to explain it to many people, it's straightforward. The thing about relationship tables that's difficult in normal databases is you have this idea of, this is like a relational database, and you have this idea where the rows and customers and the data is all kind of intertwined, right? So we have here, say we have this ordered by time, This person logged in or looked at his balance on his iPhone, and then this customer again, he went to his current account on his iPhone. So you're trying to understand what is a person doing on their application at any one time. We're just trying to figure out a customer journey for a customer, right? But most databases look like this. And that's all fine, but when you get to the stage where you have millions of people and or hundreds of thousands of people accessing data at the same time, the problem is they get stuck on this table. It becomes a real bottleneck. So what Cassandra did very cleverly, Google's big table did, and Cassandra copied, was they changed everything. They turned it sideways. And they said, well, instead of grouping all data in a big table, what we'll do is we'll group data associated with the entity, right? So my customer now, customer one, has all his journeys together, right? They're all actually together on disk. So when I query this one, I can get all the information I need back in one query. And similarly for customer 2, customer 3. And if you think back to the nodes of the cluster, these customers may be on different nodes. Right? They could be on node 1, and this guy could be on node 4, and this could be node 7. But this is how you can get the scale and concurrent or parallelism in these kinds of applications, because they don't have any concurrency. There's no contention on the table. It's all very separated. The other thing about this is you can automatically tell it to order in descending order, right? So automatically, the first one in the list of page visits is going to be the most recent one. And you think about this in life. I mean, how many applications do you go into, and the latest one is the first thing you see? Right, so you go into your bank and you see your last transaction. You go into Twitter and you see your latest tweet, or you go into. It's all about the last, right? It's about where you are currently, and then you can scroll through your history just like you would. So Cassandra was made to do made to enable the applications that we all use today. Okay. So how do we do this from a Cassandra point of view? How do we make a relationship table rather than an entity table? So what we do is we just change the primary key. So if you think back to the other one, the primary key for this was just the customer. In a relationship table, you have the customer ID, which is your entity, but you have another thing here, which is called the clustering column. And I won't get too technical on actual names of things and stuff, but this allows me to say every time a new element or a new row comes in that has a new time, put it as a new column, a new row in this partition, right? So every time someone visits a page, it will come in and give me another one here. Right? It'll pop onto the top of this stack. And the way I know it'll go onto the top of the stack, because I'm telling it to order by time descending. So I'm telling it, always put the last one at the front. Right? And what that does then is, I can do select statements like, give me the last 25. That's what that will do. Right? I don't have to tell it to order anymore. It's automatically ordered. I say, give me the last 25 customer events for this customer. Right? Very simple, but I can now, with this model, do hundreds of thousands of queries at the same time. And I can scale it to whatever size I want. Microsoft use a very similar thing for Office 365. So when you log into Office 365 and you have a problem, they automatically know what you did to create that problem, and they're in the background fixing it because they're tracing steps. And they understand you did these 10 things and had an error. Now you don't have to go, talk to them on the phone and say, I did these 10 things. They already know. And lots of people do this, by the way. So the kinds of things then we can do with this, we have this time element, and we have this idea that I can always get the most recent data. So now I can do simple queries. Obviously, give me all the transactions from the start of August, and just limit it to 25. I might be doing paging or whatever. Think of your internet banking or whatever. Very simple, very clear. Other things you can do is give me the last transaction from everyone. Right? So this will go across every single person in my bank and actually get me the last transaction. So that things like that are great for where is everybody now? You know, if you were thinking about, what's the state of the world right now? You would just go, give me everything, the last instance of everything. Okay, use cases. So we looked at this one. This is fairly, customer journey. Anybody that works in retail or plans to work in retail, customer journey is the biggest thing in retail at the moment because understanding your customer. Everybody's getting eaten by Amazon. Customer attention, just keeping hold of your customers is really, really difficult. So you have to, maybe you don't have the best product anymore. So you have to think about your customer. You have to put them first. You have to be, loyalty programs, all this kind of stuff. The only way you understand the customer is by understanding what they do every day on your site or in your store. Other examples. So what about your bank account, right? So your simple bank account, you log on, or your credit card, similar. But here's my bank account, and here's all my transactions that I do in descending order or ascending, but descending makes sense for internet banking. So how would I create that data model-wise? Well, very simply, I have my account number, and I have my transaction time. So every time a new transaction comes in, it will automatically be placed beside my partition of data and with all the rest of the transactions that are part of my account. Very efficient when you think about it. Very simple, but very efficient. And again, we say clustering order by this transaction time, the descending. So what about text messages? So for example, if I say, well, I log into my text message, and it shows me the last messages that I had. So I talked to Joe, he hasn't viewed that message, the text was this is that time, Steve, Vin, whoever, right? So again, very simple, same thing, Apple ID, my transaction time, descending order. Everybody does messages, WhatsApp. But what about the messages between two people? Well, there you have, well, actually, I've changed my key. Right? My key now has become me and someone else. So my conversation with any contact. So me having a conversation, these are the messages that are actually in when you go and you say, right, what did we talk about? And you see the history of your messages. And then you scroll up and it goes and gets more and goes and gets more. Right? This is how they store their data. So just a very nuance around this key here. So now this key is changed, right? So we still have the transaction time, but this key has changed to my ID and the contact. So now what I've done is, this one here, I've grouped all my latest messages together because it's just my contact ID. This is all my messages between me and another person. So now I've had to change this ID to make sure that I can get to it as quickly as possible and retrieve all those messages in one query. Okay. So other cool things that are really cool, apologies at the back, you may not be able to see this. In Cassandra, you can have collections as types. So I can actually have maps as columns. And I can have sets and lists. And what that allows you to do is, if you ever, without 10 minutes, thank you, I can decorate this transaction. Right? So this transaction comes in from a credit card account or something like that. And then I come to my internet banking and I say, well, actually, what was that? It's a 300 pounds John Lewis receipt. I don't know what it was. And then you say, oh yeah, I know what it was. It was some duvet covers, a blanket, and whatever, a couple of lamps. But I can actually put in the details I want. Right? This is a real world example. So I can track and say, oh yeah, I know what I did. That's what it was. And I can also tag it and say, well, this is a personal transaction. And it was a luxury item, and you might have expenses and things like that. But you haven't had to change the data model, right? You can decorate rows without having to change the data model, which is really cool, really handy. Other things you can do UDFs, user-defined functions and aggregates. So things like counts, max, mins, you can create your own. There's obviously a set that you can use, but you can create your own functions that you can use. You can use JavaScript, Java, typical things like that. So I do a lot of work with IoT, and a lot of the time what happens is you have massive amounts of data. And what happens when you have massive amounts of data is you end up bucketing data into time periods. And this is not, this is a little bit down the road if you were working on Cassandra, but what happens in that case is you usually end up creating buckets around, maybe it's a car, my car, and I have I keep data per day on my car, right? And similar transaction time and things like that. Not going to go into too much, it's a little bit down the road. I missed a slide, did I? Sugar. I had a great slide on TTLs, and I must have removed it. But TTLs are a great thing, and it's called a time to live. And what you can do is you can automatically say, when I'm putting data into Cassandra, you can say, I want this data to live for 30 days. Right? Or if it's a session or it's a cookie, I want this data to live for an hour. And what will happen is, in an hour, the data will just disappear. Like, it will literally not come back anymore. And what that's great for is when you have any history or data that you only want to keep for a certain amount of time, but you don't want to go into a production database and run delete all from where time is less than. No one wants to do that, right? So it's a really cool little trick that we use all the time. How many people have heard of Apache Spark? Excellent. So Apache Spark is a distributed processing engine, analytical engine. Databricks out there, plenty of people using Spark. One of the things that Cassandra and Spark are really good at, but when you think about it, a distributed processing engine running on lots of different nodes, and you have a distributed database sitting on lots of different nodes. And what they do really well is the kind of map-reduce concurrent parallelism that you want from big applications and big analytics use cases. These are some of the things that you do on a normal basis in Cassandra and Spark. So you can just read from a Cassandra table. You can just say Cassandra table, transactions, my transactions, or something like that. And it'll pull all the data from the table. And obviously you can filter it if you want. If I have data, I can save it straight to Cassandra, if it's in the right format, obviously. Something that's really cool, if you're doing real-time streaming. So imagine I have a load of data coming in from all these sensors all over the world. And what you can do is you can say, well, I've got, in this last 10 seconds, I've got 1 million IDs of sensors coming in. Let's say 100,000 sensors came in. And what I want to be able to do is, I want to join it with my data that's already existing. All right? So think of it like, actually a better example. Transactions from credit cards are coming in. And they're all coming in every couple of seconds. And what I want to do is I want to look at all the credit cards over the last maybe 10 transactions and see what's going on, make sense of that transaction. A lot of what we do is around context. So a transaction is kind of isolated unless you know something about the context, what's happened beforehand. How is that transaction living in the space where all the other transactions are happening? And Cassandra's really good at that because we can get all this data together. We can access hundreds, thousands of rows in a couple of seconds to start processing this and fraud examples and things like that. Context is very important, by the way. If you just know a car is going 50 miles an hour, it doesn't mean anything, right? Unless you know the car was going 45 miles an hour a minute ago and it was in this direction and all this information, then you can start to make sense of data. Per partition limit, again, is just give me the last 10, give me the last 20 transactions in this. Okay, so I've got 4 minutes. So I just wanted to get back to this. So if you take away one thing, right, there is no way that these applications could have been created without databases like Apache Cassandra. And the reason is because we have two different types of tables, remember. We have the people, the tweeter, and then all the tweets. Or we have the viewer and all the shows that he watched, right? I'll give you a quick example of how important this is. When Netflix is on peak, there's about 25 million people watching. 25 million people watching. Every time you're watching a show, every second or two, there's a transaction that goes back to the database to tell it where you are in that show. So that's 25 million, and that's not even talking about people logging in or looking at their views or recommendations. This is just about trying to help you as customers save where you are in that show. And that's for every show you've ever watched, remember. If you go to a show you watched last month, it'll remember where you were. Right? So these databases are there for a reason. And the data model there, that little bit of an extra key to allow your data all to sit together, makes all the difference in terms of being efficient and querying your data. Okay, questions? By the way, sorry, just one thing. I work for DataStax, and we have an academy, a website. It's all self-paced learning. It's all about Cassandra, all about integration with Spark. There's a lot of different free. It's all free. So if you'd like to take a look at that or kind of learn some more about Spark or Cassandra or Spark, that's a great place to start. Any questions? Yes.
Microsoft has a Cosmos DB, which is a NoSQL and has the Cassandra model.
Yep.
Is it, and underneath, is it the same Cassandra engine and it's just on top the client, or is it completely different?
That's a really great question. So Cosmos DB is Microsoft's NoSQL database. It's multi-model. It has a Cassandra API, but it's totally different. So what it is a generic, there's very generic data structures underneath. It's totally schema agnostic. You don't have to, you don't have to say it's Cassandra or Mongo, or there's lots of different interfaces. So it's totally different. It just has an API that looks like Cassandra. Yes.
In Cassandra, how do you model, how would you model when you have two queries going for different attributes? So in that example, I have most of the things going by customer ID, but now I need to query by the product that those customers.
Yeah, so that's a really good point. How do you query on items that are not the customer ID? And that's a really important point, right? I didn't go into it too much. But Cassandra is made to be able to be queried by IDs, right? It's not essential, but it's really recommended that you know the IDs of the things you're looking for beforehand. It's not a general search tool, right? If you want to be able to search, if you think about Netflix here, if you want to say, oh, give me all the people who watched Game of Thrones, that's really hard, because I'd have to go and investigate every single person. Now, Apache Spark does that really well, but DataStax itself puts on these layers. We put on search indexes with Lucene, we integrate with Apache Spark and do all that. But Apache Cassandra is not made for searching, right? It's a query-driven model. It's not a relational model. It's not for normal form or anything like that. It's very query-based.
So
one more.
So where it stores the metadata, the partition key?
The metadata?
Yeah.
So the metadata is stored in tables in Cassandra as well. So when there's system tables and tables of tables, so there's a whole system key space or instance where this, it understands all that data or where it is. It's like a catalog or metadata.
It is also distributed?
Yes, absolutely. One thing about that didn't get into too much, but I have to finish, unfortunately. But I can talk to you after. One of the things we didn't get into is Cassandra is highly fault tolerant. It's very highly available. And that's why the companies who use it. They know that the system is very hard to break and bring down. So very important. Thank you very much. I'm out of time, but if you want to talk later, please do.